Welcome to this explainer. Ever wonder how massive manufacturers, or even local mom-and-pop shops, manage to predict their future labor times and costs with just absolute stunning accuracy? Well, you're in the right place. Today, we're completely taking the guesswork out of production forecasting and replacing it with the predictable, highly reliable math of the learning curve. Let's dive right in.
Here's a quick look at our agenda for today. We'll start with the learning curve theory, move into the arithmetic doubling method, then tackle both unit and cumulative value tables, and finally wrap up with strategy and the learning curve.
Section 1. The learning curve theory.
You know, historically, this principle was actually first formally observed in the airplane manufacturing industry. They noticed something fascinating. As workers got more practice building planes, the time it took to build the next one predictably dropped. And that perfectly captures our core definition here. A learning curve is just a mathematical line displaying the relationship between unit production time and the cumulative number of units produced. Basically, as cumulative production goes up, the time per unit goes down.
And this perfectly explains why simple linear guessing just completely fails for long-term forecasting. The learning curve relies on three core assumptions from our source text. First, the time required to complete a task will lessen each time it's undertaken. Practice makes perfect, right? Second, the unit time decreases at a decreasing rate, meaning you get these massive efficiency gains early on, but then they naturally start to taper off. And third, this reduction isn't random. It follows a predictable mathematical pattern. It is exactly that third assumption that lets us actually calculate future costs.
Section 2. The arithmetic doubling method.
So, if this reduction in time is predictable, how do we actually predict it? Let's ground this with a practical scenario. Imagine a company. Let's call them Cumulative Inc. They've analyzed their historical data and figured out they operate on a 90% learning curve. Now, their very first unit of production takes a whopping 1,200 hours of labor. Our goal is to figure out exactly how many hours it's going to take them to produce their fourth unit. To do this, we use the arithmetic doubling method. The rule of thumb here is simple. Every time cumulative production doubles, we just multiply the time by our learning curve percentage. Okay, step 1. From Unit 1 to Unit 2, our production has doubled. So we take that initial 1,200 hours, multiply it by our 90% rate, or 0.90, and we get 1,080 hours for the second unit. Now step 2. To get to the fourth unit, production doubles again, right, from 2 to 4. So we take the time for Unit 2, that's 1,080 hours, and we multiply it by 0.90 once more.
And that leaves us with exactly 972 hours. That is the time required to complete that fourth unit. Just by multiplying by our 90% rate every single time the unit number doubled, we successfully forecasted our future labor requirements. Pretty slick.
Now, finding the time for one specific unit is great, but businesses also really need to understand the big picture. By utilizing cumulative math formulas, which basically just sum up the time for units 1, 2, 3, and 4, we can figure out the total burden on the company. For Cumulative, the cumulative total hours to build all 4 units combined comes out to 4,213.2 hours. Divide that by 4, and we find the cumulative average time for those first 4 units is about 1,053.3 hours per unit.
Let's try one more doubling scenario to really lock this in, but this time we'll use financial figures. Scenario 2. A local furniture shop building custom tables. They operate on a steeper 75% learning curve. The labor cost to build their very first table is 40,000 Philippine pesos. Our goal here is to find the marginal cost to build their 8th table.
Following our doubling method, let's track the drop in marginal cost. Unit 1 is 40,000 pesos. Production doubles to Unit 2, so we multiply by 0.75, dropping the cost to 30,000 pesos. We double again to Unit 4, which drops the cost to 22,500 pesos. And finally, we double from 4 to Unit 8, multiplying by 0.75 one last time. That brings the cost of the 8th table down to just 16,875 pesos. That is a massive reduction in cost, all thanks to the experience gained. But we've got to address a critical limitation here. The arithmetic doubling method is absolutely fantastic, but it only tells us the cost of the exact doubled unit, the second, the fourth, the 8th, the 16th, and so on. What if a customer wants to buy all 8 tables, and we need the average and total cost for the whole batch? Or what if we just need to know the cost of the 5th table, which obviously isn't a clean double?
Section 3. Using unit value tables.
So when numbers don't easily double, operations managers have a secret weapon: standardized learning curve tables. Let's look at scenario 3 with Card Bites Bakery. They've got an 85% learning curve. Their first elaborate custom cake takes 10 hours to decorate. Now they need to estimate the time for exactly the 12th cake. You obviously can't reach 12 by doubling 1, 2, 4, and 8. Doubling is entirely out of the question here. This is where we rely on the unit improvement factor table, found in Appendix B.1 of our source material. This table totally does the heavy lifting for us. To find the time for that 12th cake, we just look down the unit column to row 12 and then scan across to the column for an 85% learning curve. Boom! We find the exact multiplier, the unit improvement factor, and we just apply it to our 10-hour starting point. It's incredibly efficient and completely removes all that complex logarithmic guesswork.
Section 4. Using cumulative value tables.
Knowing the time or cost of a single specific unit is definitely helpful, but broad logistical forecasting requires cumulative totals. Before we dive into the cumulative table, I want to draw a really clear distinction that's highlighted in our source text. There is a huge difference between unit time and cumulative average time. Unit time drops rapidly. I mean, the 20th item you make will be way faster than the first. However, the cumulative average drops much slower. Why? Because those early, slow, expensive units you built at the very beginning essentially act like an anchor, pulling the overall mathematical average up. To calculate these cumulative totals without breaking a sweat, we use Appendix B2, the table of cumulative values. If Carb Bites Bakery wanted to know the total time required to make all 12 cakes combined, they wouldn't just sit there and add up 12 individual calculations. No way. They'd simply refer to the table, find row 12, scan over to the 85% column, and grab the cumulative improvement factor. Then they simply multiply their initial 10 hours by that factor. One simple multiplication, and you have the total hours for the entire batch.
Let's apply this superpower to resolve our local furniture shop problem. We know their first table cost 40,000 pesos, and they're writing a 75% curve. To find the total cost for all 8 tables, we just find the cumulative factor for Unit 8 at 75% in Table B2. That factor is 4.802. We multiply our starting cost of 40,000 pesos by 4.802, giving us a definitive total cost of 192,080 pesos for all 8 tables. And if we want the cumulative average cost, we just divide that total by 8, yielding an average cost of 24,010 pesos per table. It's fast, it's accurate, and it is absolutely crucial for setting a competitive retail price.
Section 5. Strategy and the learning curve.
So we've crunched the numbers, but why does this actually matter to a business? Because these mathematical techniques directly translate into a real-world competitive advantage. Let's quickly review what we just pulled off. For Takatoon, we use the doubling method to instantly find the time for a 4th unit on a 90% curve. For the furniture shop on a steep 75% curve, we use the cumulative table to pinpoint exactly how much a bulk order of 8 tables would cost. And for Carb Bites on an 85% curve, we use the unit table to snag the exact time for a non-doubling unit, the 12th cake. Identifying the right tool empowers businesses to scale production with confidence, quote accurate lead times, and, most importantly, set profitable prices.
I want to leave you with a final provocative thought to ponder. We've seen firsthand how dramatically costs and times decrease as cumulative volume increases. So ask yourself this. If your competitors are accumulating experience and moving down their learning curves faster than you are, how long until your current pricing strategy becomes entirely obsolete? Mastering these equations isn't just about passing a math test. It's quite literally about survival in the marketplace. Thanks for joining me for this explainer. Keep learning, keep calculating, and we'll catch you next time.